Um, I'm going to have to improvise a few things today because I've managed to screw up my GitHub repo, but I'll fix it after class. Um, okay, so I wanted to talk a little bit more about the image stuff, namely how do you get it working not on the um, not within Runestone. And in order to do that, let me first get an image of some sort. And I'm just going to pick something something stupid. Let's do. So the assignment is inspired by, or the graphics assignment is inspired by a bunch of Andy Warhol things where he has a bunch of pictures of something, but in different colors. So for example, if we go to just the images thing here, some of his very famous images are things like this, where it's the same picture or the same image, but he silk screened it in different colors, and it makes it look interesting. Um, okay, so nothing particularly special about that. So what I'm going to do is I'm going to steal this image, and I'm going to put it in the GitHub repo with images, and I'll just call it here soupcan.jpg. Okay, whatever. Okay, so what we basically need to do, there's sort of two processes. If I wanted to make some sort of grid like this that has multiple copies of the soup can in different color schemes, right, is first I need to get multiple copies of the soup can to show up on the screen. And then the coloring is the image processing stuff, and that I'm going to leave to y'all because that's where the creativity is going to come in, to come up with how do you want to manipulate the color channels, the red, green, and blue values, to make it look different. Yeah? Okay, so if we go back to here, then the first thing we need to do is we need to import our library, okay? And depending on, I've had trouble doing this. The book says to do the following, or sorry, says to do this, okay? But what happens? What's with the squigglies underneath? That tells us something, and if we hover over it, it tells us that it doesn't know where CImage actually is, okay? So it seems to me at some point, the people that, yes. What now? To what? Well, so that's not the problem though. The problem is that Python doesn't know where CImage is, right? Even though we installed it, okay, with pip3. So what I had to do on mine, and it appears that we're going to have to do on here also, is actually download the thing from their GitHub repo. Okay, so if you just do this, it should work. Okay, so they changed the name of the package. Now, I also had the problem where even though I had image installed, Python was unable to find it. That's a me problem because I've got like 15 versions on here and I'm trying to clean them up. So what I had to do was actually put the image.py file that they wrote in the same directory as my project. Okay, and I got that file from their GitHub repo, and which I'll show you in a minute because that actually is going to be important for something that we're going to run into. Okay, good? All right, so how do I open an image? Well, the first thing I'm going to do is and what was it? What was my file called? soupcan.jpg. Okay, so this will allow me to open a file, which is in this case is an image file. As long as you also have installed Pillow, you should be able to use JPEG, PNG, and GIF, however you choose to pronounce that. as your file format. But if not, it's not that hard to convert an image from one file format to another. Okay, so we then have created an object called img1, and that object is the sort of associated with that file. Okay, now what we want to do, of course, is to put this thing on the screen. Okay, and in order to do that, I first need to define a viewing window, and I'll do this as follows: image.image win, and let me just do, for right this instant, I'll do 640 by 480, but that will change in a minute. And then I'm going to give it a name, which you'll see what this does in a second. And then you remember with the turtle package that we had to have that thing down at the bottom so that the program wouldn't immediately close, right? We're going to have something very similar here, and it's when exit on click. So the window will stay open until we actually click it. It will detect mouse events, and then there we go. Okay, so good? Yeah? Yes. Did you install it with pip3? Okay, so if that's the case, the other thing, and you're on a Windows machine, right? So the other thing, when you install packages, Python doesn't necessarily know where those packages are, and you have to add the directory that they are in into an environment variable that says, hey, go look over here for things. And the link I posted on Canvas should show you how to do that. There's a couple ways in Windows system settings to do it. On a Mac or Linux, it's a different procedure, but the same idea, okay? So if you have that problem, the immediate fix is just download the image.py from their GitHub repo, and there's a link in the book, and just put that file in the same directory as your project, and then it'll work. Okay, so that's the temporary fix. Does that make sense? Yeah. And I'm going to do that here in a second, because we actually do need to go look at their GitHub repo for documentation purposes. Okay. All right. So if I run this, then nothing particularly fancy is going to happen at the moment. Oh, okay. Right. It won't let me do a JPEG. Okay. So let me do a conversion real quick. And it says only GIF or PPM, which of course is not supported here. Okay. All right, let me just find another image that's a GIF. How about this one? Okay, it's got their watermark, but who cares? This is just, oh, that's not what I wanted. Damn it. Okay. That's an animated one. I don't want that. Don't want that either. Yeah, I could, but you know what? Let me just do this. Let me just upload my GIF to Canvas, and then I'll download it. And sorry, this is a little slow this morning. Come on, Safari, you can do it. Well, or here, let's just do this. Forget Andy. Let's just get a Wally Wabash. There we go. Okay, so that one happens to be a GIF file. So forget the soup can. Let's just do wally.gif. Okay. Okay, so now if I run it, oh, no such file. Oh, sorry. Okay, I know why this happened. So you have to change your directory here to the actual directory that the image is located in before you run it. Okay, and there we go. So my window pops up, but of course, absolutely nothing is being displayed on it because I haven't told the image library to actually put anything on the screen. I've just said make a screen. Yes, Mark. So I had to change directories in the terminal. So if I kill this, so when I first open up GitHub by default, or open up VS Code, the directory that I'm in is my root directory for my entire project. But that's not necessarily where the file that I'm running is or where the image is. So I have a subfolder and I need to change directory into that subfolder, which in my case, I called it images. And then, right, so I'm typing ls here to list the file structure. On Windows, that's dir, unless you're using a PowerShell, in which case it's also ls. It uses the Linux names or Unix names. Okay, so I haven't actually drawn the window or drawn the screen, sorry, the image to the screen yet. All I've done is just make a screen, okay? Now, let's talk about some of the methods that we need to use. Okay, and GitHub is just like freaking out here. Um, um, so in order to draw this image to the screen, there's sort of two issues that I need to deal with. One is 640 by 480, that was the size of the window that I drew, but that may not be actually the size that I want because how wide is this image and how tall is this image? Well, right now I don't know, but I can find out by saying width equals, and it's image one, that's the name of the image, get width. Yes. Yes, and the reason I'm doing it here as a separate variable is going to need this number for other things also, and that way I've already got it, okay? So I can also do the same thing to get the height, right? And then here I can just say width and height instead of the fixed number 640 and 480, okay? And so now if I run this, that's the exact size of the image. And so my screen is the exact size of the image. And so my image will fit perfectly when I actually put it on the screen. Okay, so is that good? Okay, now I need to actually put it on the screen. Oop, and I shouldn't have done that. So how do I do that? What I need to do is, let's see, where is it? Okay, image.draw, image1.draw. And then I need to say, well, where am I drawing it? I'm drawing it to a window. And what did I call that window in this case? Just when, right? Whatever. Okay, so does that make sense? We? No. Yeah? No? Doesn't work? Okay. So yeah, you got to have the image, the, the image. So if the path doesn't work, you've got to download the actual image.py into the directory that your project is in for it to actually find it. Okay. Huh? From GitHub. We'll go there in a second because we need to go there for something else anyway. Okay. So now what should happen? Should draw it and put it on the window, and it's all going to fit very nicely. Okay. So let me run it, and lo and behold, there's our Wally Golf dude. Okay. Good. Now, if I want to make an Andy Warhol style image out of this, what do I need to do? Right? What's the problem? What have I drawn so far? I've only drawn one copy of this, right? The Warhol images have what? Multiple copies in some sort of grid, okay? So let's do, for sake of demonstration, 3 across and 2 down. And I'm just making up that number. It doesn't really matter, okay? So what I need to do then, and is if I want to do 3 across and 2 down, what does the width and height of the window need to be? 3 times the width and 2 times the height. Yes? Okay. Now, if I run it, then here's what we get. We've got a window of that's got space for 6 Wallies. And we've plotted one of them, and where did he end up? Starting in the top left corner, okay? That's logical. So if I want to have 5 more of the Wallies, what I need to do is basically clone this object 5 times and arrange them so that they're in the appropriate positions on the screen. Because if I just clone 5 of them, then they're all going to appear right on top of each other, and that's clearly not what I want, okay? And this is where the GitHub part will come in, okay? So I need to know, how do I put this thing somewhere else on the screen? Basically, I need to be able to reposition the image on the screen. All right, now, before I do that, though, I also need to make some copies of it. So let me do image2 equals image1.copy. And all this does is clone image1 into image2. And I need to do that a bunch more times. 3, 4, 5. Okay, so then I've got image 3, 4, 5, and 6. Okay, and in this case, because at least in the Andy Warhol stuff, you use the same image for all the panels, and then you're just going to mess with each one. That's why I did the copy. If you had multiple images, then obviously you wouldn't copy them like this. Okay, good. So I've just copied the images, and now down here, when I want to draw them, if I wanted to draw the second one, for example, I would just do that, okay? But what's the problem I'm about to run into? It's going to draw the 2 of them right on top of each other, which is clearly not what I want, okay? So I need to figure out, how do I move one of them so he appears here, and then similarly with the rest of them, okay? All right, so let's go to GitHub, because we're going to have to look at basically the source code to figure this out. Okay, so GitHub Python image, and let me look at Runestone because it's got the actual link on it. Because this is probably the worst Google search ever to get to where we want. So if you're on Runestone, the link is in Chapter 8, Section 12, Image Processing on Your Own. And the URL is this. So it's github.com/BNMNETP. Oh, sorry. BNMNETP. Okay, and that'll take you to this dude, right? So he was a professor, is still a professor at Luther College, which is in Iowa, small liberal arts college, not too dissimilar from us. And CImage is the package that we're using, so we'll go to that repo. And some of it could probably use a little bit of updating, as you can see, okay? And if your thing isn't finding the package, here's what you do. Download image.py and put it inside your project's directory. That's what I'm having to do on my Mac, okay? So this also means don't name your file image.py, because you can't have 2 things with the same name. All right, now if we click this, it will actually show us the source code for it, okay? And essentially what he's done here is simplified another existing graphics library basically for making this quick and educational purposes, okay? So we're not really using the, like, I don't know, this is kind of like me teaching you to drive on a 57 Chevy with a manual transmission before I give you the keys to the Tesla Model S that's Plaid edition, right? Which one is probably better for you to learn to drive on? The 57 Chevy where, like, you know, it has no bells and no whistles, as compared to, say, the brand spanking new Tesla, okay? Okay, so if we look through this code, we're going to find something important, which is how do we set the position of our graphics object on the screen, right? That's basically what we need to know, is how to set position. Okay, make sense? All right, so how do we find things in a document? Yeah, if only we had Control or Command F, right? And so let's search for position. And let's see, get mouse, blah, blah, blah. That doesn't look like it's right. Okay. All right, so here's where it is. All right. Yeah, line 471, defining a function called set position and set the position in the window where the top left corner of the window should be. And then, for some reason, he defines another function called self postion. Notice the typo. That all it does is call the other function that was right up above it. Okay, I'm not sure why they did that. There's maybe a good reason. But yes, okay. So we now know how to set the position of the of a graphics object using either of these two functions. Okay. All right. So let's see how we use them. Okay. So it's set position, and then we don't actually have to say self when we call the function, and we'll talk about what the self means later, okay? So let's go back to our file, and we should do, in our case, image 2. Where should image 2 be? Image 2 dot set position, okay? We need to set its x and y coordinates of where it would be. Now, if I put in 0, 0, where should that put it? Still at the top left, okay? So if we run that, we see exactly that, right? It's still at the top left. And if I put something like 10, 0, then, well, that maybe wasn't enough to see it. Oh, I forgot to save it, that's why. Okay, we can see that I've adjusted its x coordinate, but not its y coordinate. And have I adjusted the x coordinate by enough? Now, I picked 100 out of thin air, but what's the correct number to put there? Whatever the width of the images are, okay? So I'll change this to width, like so, and now my second image perfectly lines up with the first one. Okay, is that good? Oui or no? Okay, so what do I need to do to get the other four, excuse me? Yeah, just same thing, right? So how many copies of the image have I created? I created 6 of them. And so what do I need to do for their positions? What's the next one going to be? 2 times the width, right? So I could do image 3 set position 2 times width, with no height adjustment. And then where's image 4 going to be? It's not negative, actually. Yes, okay, so thank you for saying that, because that reminds me of something important. What was the coordinate system when we were using the turtle package? Where was the origin? In the dead center of the screen. And which way did the positive x-axis go? To the right, like usual. And which way did the positive y-axis go? Up, like usual. And when I say like usual, I mean in math. That's not the same coordinate system that's used in this image package. Where's the origin in the image package? The top left corner. Which direction does the x-axis go? To the right. Which direction does the y-axis go? Down. So the positive y-axis goes down, not up, in this image package. And that's pretty standard in computer graphics, by the way. Okay. What this means, by the way, is that the coordinate system for graphics is left-handed. And you guys may or may not know this already. There are many things in this world I dislike, but none so much as people who are left-handed. Okay. I know. Well, okay. Maybe I dislike Jacob more than left-handed people, but they're a close second, right? Okay. Yeah. Okay, so it just means it's a left-handed coordinate system, and it doesn't perfectly match the coordinate system for math class, which means you have to mentally convert and flip the y-axis when you're doing math. Okay, yeah. That's not the same for the Python library.
I did it once, it worked, and then every time I tried to do it back.
So I don't know why it does this. Yeah, you have to like try it again. Yeah, so I've had this bug too. Just save everything, quit VS Code, restart it, and then I don't know why it does that, where it just won't launch things randomly, because it seems to be random. There's got to be a good reason for it, but yeah. Okay, so where do we need to set the position of the fourth one? Do we need to adjust his x coordinate? No, but we do need to adjust his y coordinate, and even though it's going down, the y-axis positive goes down, so that's why it's height here and not negative height. Does that make sense? Yes? Okay, and then what do I need to do with these? I need to also draw them to the window, and image 4, draw to the window. Okay, so now if I run it, I've got the first 4 of 6 Wallies, and you guys get the idea of how you'll get the other ones on there? Yeah? Okay, so that answers the question for the Warhol project as to how do you get the multiple copies of the image on the screen. Okay, what's the other part that we need to, or y'all are going to do? Change the colors somehow to make it look cool. Okay, and again, I don't know what look cool means. The other thing about the Warhol stuff is, so here's what I would do. Leave the top left one unmodified, so we can just see what your starting image was. And then all of the other images, what are you going to do to each one? Differently. Key word there, right? Because in the Warhol images, are any of them the same? No, they're all different. Okay, so come up with however many different kind of color manipulation techniques to make it all of them look cool, right? And what look cool means, again, I'm leaving that up to you guys. Okay, is that all right? Okay. Now, the runestone, like the example we pulled up last time, showed us a method of changing the pixels, right? Changing the red, green, and blue pattern. And what was the runestone example? What did it do? It sort of negated the image, but how did it do it? If a pixel has a particular red, green, and blue value, what was the new value in 255 minus the old value is the new value. And so it essentially flipped the color palette And so we got the negative of the image in sort of like an old photography kind of sense. Okay. None of you are allowed to do that, right? Do something different than the example. Okay. Huh? Oh, but I mean, come on. There's so many other ways you can mess with it, right? Okay. The other thing is, what image are you going to start with here? I just grabbed this Wally golf thing. Do I care what image you start with? No, as long as it's you know, at least rated PG-13 or under. Okay. Then it doesn't matter to me. But you need to include that file with your submission because otherwise it won't run for me, right? Does that make sense? Okay, so that's thing one that I wanted to hit from the end of last time. Okay. Thing two is we need to do a little math real quick because that's, and I've forgotten to remind you guys about this last time, which is for the turtle library that you guys are building, right? How do you do a star? Well, I think one of the examples did a 5-pointed star in the book, and you might be able to generalize from that, okay, to figure out other stars, okay? But what's sort of the problem with the star is you have to figure out what the angle is to turn, right? Well, how do you figure that out? Okay, that's certainly one way to do it, but what's a better way to do it? What would an excellent student do, Mark? Math. Yeah, okay. So here's my hint for how to figure out the math for that. Let me, for sake of example, draw a pentagon, or actually, let me do a hexagon, just because I can't draw. Okay, and that would be the hexagon, and we've already figured out what the angles and stuff are for a hexagon, or any polygon for that matter. Okay, so let me inscribe in this thing a 6-pointed star. Right? And notice what each leg of the star is. What does it connect? Two vertices, but it skips over one of the vertices. Yeah? Does that make sense? Okay, so I have a triangle there. And if I call this length x and this length d, well, d is the same as the length of the side of a polygon, and we've already figured out that math. Okay, so how do I figure out that side length x? Well, let me draw a copy of this triangle, right? What is this angle here? Do we know what that angle is? Yeah, we figured out that math already. And do we know what this distance is? Yeah, we figured that math out already. It's the same as for a polygon. And what we're interested in is what is that length? Yeah? All right, does anybody remember a relationship between dx and theta? Okay, let me draw another triangle just to remind you. If I have a triangle, ABC, with included angle theta here, then what's the rule that I want here? Looking at you, physics major, you better just know this off the top of your head. It's trig, yes. We need the law of cosines, which is c squared equals a squared plus b squared minus 2ab cosine of theta. And you guys all remember that from high school, right? You don't? Justin, you're killing me, man. Okay. This, sometimes it's actually called Al-Kashi's theorem, by the way. What about if theta is 0? Or sorry, theta is 90. What's cosine of 90 degrees? So what happens to that minus 2ab cosine theta part? Poof. And if theta is a 90-degree angle, what do we have? A right triangle, and this collapses down to Pythagoras' theorem, right? So this is just a generalization of Pythagoras' theorem to non-right triangles. Well, that's useful. Now, do we know theta? Yes. Do we know A and B? Yes. In this case, they're both the same. Therefore, can we figure out C? Yeah, because I think you can take square roots. I would hope you were able to do that. Yeah? Okay. So, it's a little bit of math. Yeah? Okay. Now, if you figure that out, that tells you how long the turtle needs to move when drawing a star. But then the other thing that we have to worry about is we also need to know what this angle, and let me pick a different color here. We also need to worry about what this angle is, or this angle, or that angle, right? Now, let me actually pick a better color here. This angle and this angle are the same, yes? And this angle, what would be 2 greens plus 1 blue? Or, sorry, 2 blues plus 1 green. Yeah, that adds up to theta. Okay. Furthermore, the blue angle is the one that I drew here. And in our case, we have an isosceles triangle, so that one's also the same. Therefore, what do you know about the 2 blue angles plus theta? They have to add up to 180 degrees, and therefore you have everything you need to know to solve for either the blue or the green angle, whichever one you feel like you need. Right? So hooray, math. Yeah? Not so bad, was it? And seriously, none of you guys remember the law of cosines from high school? Well, you guys also got really shortchanged because when were you guys taking trigonometry? At home, right? And we all know how much e-learning sucked. Yes? Who wants to go back to that? Huh? Being in your bed in your pajamas and going to class is kind of nice. It was nice for 2 weeks, and then we all realized how much it sucked. Okay. Yeah. Okay. But look, that formula is not that complicated, right? I haven't even done any calculus today. It does. Um, Now, if you have an angle of 180, you have a really silly triangle, but it is technically correct. Okay, so that's maybe not the only way to approach the question of the star. Maybe you guys have figured out a different way to do it. In the end, you will end up getting the numbers that you would get out of this, even if you think about it a different way. Okay. All right, make sense? Cool. All right, let's get back to programming. Okay, because the next set of stuff that we need to talk is going to get a little bit long, and so we'll probably have to continue with this on um, Thursday. Oops, that is not what I wanted. I wanted a folder. Okay, so the next big topic is strings, which is chapter, I think, 9 in Runestone. And there's a lot here, so we probably won't be able to talk about the whole thing today. We'll continue with it on Thursday. So, what is a string? And we've already used them a bunch. For example, when I did something like back at the very beginning of the semester, we did something like this, right? Print hello world. And if I ran it, then, okay, great. So what is a string fundamentally? Yeah. It's a series of characters, okay, or an array in some sense of characters, right? What is the first character in this particular string? The capital H. What's the second one? The lowercase e, and so on, okay? I can have as many characters as I want in a string, and there are different ways of denoting that you have a string. So in this case, I just put it in a quotation marks, right? But what about if my string needs to have quotation marks in it? Well, then I can do something like this. For example, I can double quote it, which I hate doing because it looks awful. Or here, let's do it this way. Um, um, right? So if I put the string in triple single quotes, that allows me to have nested double and single quotes inside my string. Okay, and so that way I can do this without it looking, without too much trouble. In C, which those of you guys who continue on, other languages handle strings a little bit differently, and you'll get that when you get there. Okay, so there's lots of ways to define a string in terms of the quote mark part, but what really is it fundamentally? It's just a bunch of characters strung together, hence the name. Okay? Okay, so I can print these things. That's not all that interesting. But I want to be able to do processing with them, modify them, or make new ones out of old ones, or do other things like that. Okay, so what kinds of things might we be interested in doing with strings other than just printing them? Okay, finding a word, whether or not a word appears in a given string. That would certainly be useful, right? Now, in a short string like this, it's not really all that hard, but we could do that. What else? Huh? List in what sense? Keep talking. Oh, okay. Um, yeah, like putting one of these together based out of a list of words. So, for example, how many of you guys have ever done like a Mad Lib thing where it's like a sentence, but there's a bunch of blanks, and then you have to put a particular part of speech in that blank? If you had a collection of strings for that were adjectives and another group that was a bunch of nouns, then you could randomly pick an adjective and noun and whatever to make a Mad Lib. Yeah? Okay. What else? Well, if I've got a string, maybe I would like to know how many characters are in it or its length. It might be useful, right? If I can search for words in them, maybe I want to take a string and like get a certain little chunk of it out. So I want to extract a smaller piece of a given string. Okay, and maybe I want to modify things. So for example, in this case, my text is in, well, most of it's in lowercase and some of it's in uppercase, right? How many of you guys have typed in like yes, no into a computer program? Does it matter whether or not you type a capital Y or a lowercase y? In many cases, no, okay? So what's actually happening there is what do you type, when you use the input function in Python, what data type is it attaching to your input? String, okay? Now, if I type little y and you type capital Y, those are different things. So how could I make my program realize that really they're the same thing for that purpose? They're both indicating yes. Well, I might want to be able to say, take this lowercase thing and make it uppercase, or vice versa, right? Um, and right, so all of those kinds of things that I might want to do, we can do with string, um, with the string object, okay? So let me just talk about a couple of examples of this. So let me call string one equals, how about hello? String two equals world. and string 3 equals Wabash. Doesn't really matter what they are. I'm just making something up. Okay. So how long is string 1, string 2, and string 3? Just looking at them. Yeah, they're each one word. How many characters? 5, 5, and 6. Okay. So how could we get the length of the string? What's the function that we want to use? Yes, len. Okay. And so what I could do is I could print, for example, len of string 1. Okay, so what is that going to do? This len function, what is it going to tell me? Hopefully. How many characters there are in my string. Okay? All right, so let's run it. And I'm putting the print there just so it actually will tell me that number, right? And sure enough, this first one has only 5 characters in it. That makes sense. What's wrong? Oh, yes. Okay. The quotes don't count. No, that's actually not stupid. Well, if anybody else had asked a question. Oh, that is stupid. Okay. Yes, because if you wanted that, you would do this. Right? Okay. So string 1 and the string containing the letters string1 are 2 different things. Okay, so does that make sense? Yes? Okay, so I can compute the length of them, and then I could ask, what's the first letter in string 1? I mean, it's obvious to us, right? We can read this, but what is it? It's the H. How do I get that out of Python? So if I wanted to print just the first letter of the string, here's how I'm going to do it. Okay, I'm going to do string 1 bracket of 0. Now, how many of you guys are bothered by the fact that it's bracket 0 and not bracket 1? Okay, why are you bothered by that? It does, okay, but where do we start counting in computer science? Generally, we start counting at 0. That's why it is that way, okay? Here's the other reason that that's actually a good thing. Let me do this. Right? So what should this do? And let me delete that. Yeah, it's going to print each character on a separate line. Okay, yeah. Yes, but I've deliberately not wanted to do it that way. Okay, because then I is a character, not an integer. Okay, right. So what have I done here? I've printed the string by just printing it one character at a time, and the print command automatically hits enter when it's finished to create a new line. And so that's why all 5 appear on a separate line. Okay. Now, for printing purposes, is that particularly useful? But what it illustrates is that I can get to any letter in a string individually. Okay, and that might be useful. For example, if I wanted to write a function that computed the length of a string, well, first off, do I need to write said function? Why not? Because it's already there. The len function does that, right? But let's say we didn't remember that there was a length function. Can we write our own? Yeah, well, let's do it. How about it? Um, okay, let me comment this out for just a second because I want to illustrate something. What happens if I try? So how many characters are there in the string one? We said 5, right? So let me say that I try and do this, right? What should not string one? What should happen here, or what's the issue with what I just typed? There is no character 5, right? There's 0 through 4, but there is no 5. Okay, so what's going to happen if I try and do that? String index out of range. Okay, and right. Okay, so um, sorry, hang on one second. The well, okay, I'd probably want to do it this way then. Um, so in C, um, this is this is something that is sort of hidden, and since Python is built on top of C, it's technically there. Um, how many characters were in this first string? Hello. 5. How many bytes does it take to store it? Well, that's a good question, right? It actually takes 6. Okay, and the reason in C is every string has a little special character on the end of it that tells you that you've hit the end of that thing. Okay, and that's sort of hidden from us here. Okay, so if I wanted to determine the string length without cheating and using the string length function, I could do what Thomas said a minute ago, which is say something like for I in my string, counter plus plus. Well, let me just do plus equals 1. And then return counter. So what that's going to do is go through basically character by character until it hits the end and count how many we've gone through. Okay, now let's test it and make sure that it actually works the way it's supposed to. All right, so what do I need to do here? I need to print my string length of string 1. And what should we see? 5 and 5. Okay. Okay, is it particularly useful that I wrote this string length function? Like, would I ever actually do that in practice? Why not? Because there already is a built-in function to do it. Okay, but it's useful to know how the built-in function actually works, or maybe a way of implementing the built-in function. Okay, is that okay? Okay, so let me pause. Question, preguntas, Fragen. Okay, so maybe to conclude today, I want to talk about something that at first is going to seem extremely pedantic, but it'll be important for us to think about later, okay? Which is a thing called mutability. So let me just make a new file. Is that okay? Just to clean things up a little bit. All right, let me define a string. Okay. All right. So what I can do the length, right? I can even do something like this. I could do print my string dot upper, and what's that going to do? What do you think? Just returns it all in uppercase, right? Okay, so there are lots of different methods, and the book has a list of all of these. So it's got, uppercase, lowercase, capitalized, strip, which pulls out spaces. You can count the number of items that occur. So, for example, I could do something like print my string dot count, and how many letter H's appear? Well, let's find out. It's only one, G. Big shock, right? But what about if I do a lowercase h? Why is it 0? Because there's no lowercase h in my string, okay? So there can be uppercase, there can be lowercase, and those are encoded differently, and that will become important later. Okay, now, can I change the string? Sure, how? What do you want to change it to? Okay? Oh, and let's print it, by the way, while we're at it, just for giggles.